very glad to introduce Dr. Friedrich Reinhard. As you know, an intermezzo is an interlude between different acts and events. So this is something away from medicine. Dr. Reinhard is a microbiologist from the EPFL in Lausanne, who's working in the Wildlife Reserve in Namibia. He collaborates with the Rösel and the Marc Ungeheuer, two engineering students from RWTH Aachen University, on a method for wildlife surveillance using drones on machine learning. So we are very excited to listen to this interlude. Thank you, Dr. Reinhard. You're still muted.
Hello, you can hear me?
Yes, now yes.
Brilliant. Hello from Namibia. Yeah, thanks for inviting me to this session. I will start sharing my screen now. Okay, let's start with this intermezzo. I'll be talking about wildlife protection in Namibia and Africa using drones and machine learning. Here's a little overview. So I will be taking over the first part, and that's to do with wildlife and land use in general in Namibia, with the mapping project, the drone mapping project that we are conducting on a wildlife reserve in Namibia, and then the potential of machine learning and wildlife management. And the second part will be then taken over by Marc and Christopher, and they'll be talking more specifically about the quantification of this wildlife reserve using machine learning and about the association that we set up for that purpose, WildTech Aachen. Okay, so that's just a snapshot from the IUCN webpage, and just stating that at the moment we are losing biodiversity due to human intervention, and that's about 40% of amphibians that are being lost, 26% of mammals, conifers, birds 14. So those numbers don't look very good. And at the same time, when we look at Africa and especially at Namibia, we in Namibia where I grew up, we can proudly say that we have a constitution, and the first constitution of any country that actually incorporated nature conservation into its constitution. So saying the state shall actively promote and maintain the welfare of the people by adopting policies aimed at the maintenance of the ecosystem. So our constitution actually links welfare of the people with functioning ecosystems. When you look at this map of Namibia here, you can see all those black parcels are actually depicting little farms. And when I talk about farms in Namibia, commercial farming, those are in general 5,000 hectare big farms. So because Namibia is quite a dry country, the farms there are much bigger. And on about over 90% of those farms farm with cattle and sheep. So that's free range farming. Some of the farms have specialized on wildlife. And one of those farms is Kusikus Wildlife Reserve, where I am the manager of and where I grew up at. Just to give you an overview, if you zoom into those farms in Namibia, using Google Earth, for example, you can see a distinction between wildlife farms and sheep and cattle farms. The wildlife farms, normally, they just have one border fence, but they do not have, are not parcellated with inner fences. And those inner fences on sheep and cattle farms, like here, they are needed in order to control the grazing pressure over the year. In Namibia, we have a short rain season, we have long dry seasons. So the farmers, they need to basically ration the grazing and control the grazing pressure. And the way that it's done on cattle and sheep farms is by driving sheep and cattle from one fenced area to the other within their farms. If you don't do that, as you can see in the image below here, that, for example, too high grazing pressures in combination with droughts, that can lead to a drastic change in available grass and available nutrition for the animals. Having said that, on wildlife farms, it's impossible to control grazing pressure using fences because wildlife doesn't like fences. They get stuck in the fences. It's not a very biodiversity friendly way of farming. So we need to find alternative ways to manage a wildlife farm. Zooming into Kusiko's Wildlife Reserve, you can see one border fence, the outside, and you can see a lot of little roads that are being used by horse or by car in order to get around this area, which is roughly about 10 by 10 kilometers big. Within Kusiko's Wildlife Reserves, there are several water points. In order to, these water points are artificial water points mostly, so that animals have drinking water available. Only in very good rain seasons, like we had this year, there's surface waters from the rains. The farm like that typically has different vegetation types, and this whole map has been done by one of our students just by walking around the farm and using normal fieldwork ecological practices. Okay, so the wildlife resource, what's the resource? It's important to understand the resource. It's in comparison to sheep and cattle, wildlife has an inherent resource, and that's stemming from ecotourism. Even feed production would be a potential wildlife resource. But for most, it's sustaining a biodiversity. And of course, in Africa, giraffes, black rhinos, and zebras, all of which can be found on Kusiko's, would not be possible if Kusiko's was still, like when we started the project, it was still a sheep and cattle farm. This is only possible because we don't have enough fences and because we provide the water. Just one example is the Black Rhino Custodian project. That's basically a project initiated by the government of Namibia. That the government of Namibia have seen that national parks in Namibia, which are roughly about 12% of Namibia's surface area, this is not so much. If they want to effectively mitigate the eradication of the black rhino because of poaching, they'd have to actually integrate wildlife farms in Namibia. And so that project was initiated in 1992, and we've been part of it from the early start. And by use of the Bushman trackers, local experts, the project on Kusiko has been highly successful, as on the other custodian farms, so the private sector collaborating with the government. So black rhinos in Namibia are always government property, but wildlife farms take care of them. It's at the moment, it's less than 30 wildlife farms taking care of a third of the population of Namibia, and the black rhino population of Namibia makes 50% of the worldwide black rhino population. So currently there's only 4,500 black rhinos in the world, and about 500 of these are located on wildlife farms like Kusiko's. This just goes to show that we are proactive, that we're working together with the state of Namibia. Unfortunately, because of the poaching pressure, Namibia has decided to dehorn its rhinos. Rhino horn grows back, so it's not all that bad, but it just goes to show how big also the threats are stemming from poaching. So monitoring of rhinos becomes very important. Another wildlife resource is this agrotourism. I would always say ecotourism. That's basically tourism in Namibia. I'm sure some of you have already heard of Namibia or even been to Namibia. Because of functioning ecosystems and a lot of different biodiversity, it's a great country to visit. I also mentioned wildlife as a resource, so meat production. In fact, in Namibia, a lot of wildlife meat is being consumed, and it's not just for workers on the farms, but even they have wildlife meat is being sold as biltong, that's like viande séchée in Switzerland, so smoked meat and so on. So if you go to any shop in Namibia or any service station, you're quite likely to find wildlife meat. And so wildlife can also be a source of meat production, and I would even argue it's quite a biodiversity friendly way of food production in arid and very dry countries where it's not really possible to grow plants. The wildlife resource is also important, or can also be coming from live capture and sale. You've seen how fragmented the country of Namibia is, and South Africa as well. And so these natural wildlife migrations cannot actually happen anymore. And this is partly compensated by live capture and live sale. So whole herds of animals are being counted, being captured, like you can see on this image, using big boma structures, we call them, with curtains in between, where wildlife is driven in by helicopter and loaded onto a truck, and then being transported to another wildlife area or to another park. Even the European Union is still heavily involved in those translocations from private farms into parks or into areas where new populations want to be established. Droughts, of course, and climate change can be a big problem in Namibia, and especially on the farms. You can see here a picture on the left was taken May 2017, and a picture on Kusicus on the right 2 years later, when we had one of the biggest droughts in the last 50 years. And you can see this drastic change, no grass basically left on the right. Here again is another example of that. And well, what is wildlife management? So in order to prevent those droughts impacting us wildlife farms too much, we need to manage wildlife, and in a different way than we were used to manage sheep and cattle, because there's no fences on the farm. How can we do that? That's a question. So at the moment, and in the future as well, we always need the domain experts, I call them. So these are the Bushmen people, for example, and the people that locally live on the wildlife reserve, but we need to join forces with data experts. This is just basically wildlife counts is one measure of, very important measure of the management of the wildlife. But basically it looks like we are flying in a helicopter and we're trying to count the wildlife from the helicopter. And you can see everything is quite shaky. I've got a little paper on my knee and I try to count everything that's on the right. And the pilot Dirk is trying to count everything that's on the left. So it roughly works, but it's not a very accurate measure of counting your populations on a farm, which is key to wildlife management. So is there something, oh, okay. This is just a small table showing wildlife counts that we've conducted by using helicopter counts from 2015 all the way to 2020. On the left, you can see the species. You can see all the rainfall. Takeaway message from this table is basically in the drought between 2018 and 2019, heavily impacted wildlife numbers. To the extent that we lost populations, or the populations were reduced. It's not all lost, but just a reduction of 80, sometimes 90% of populations. So we had to basically foresee the drought, which we successfully did on Kusicus, and then sell as many wildlife, as we thought is necessary, but also then hunt a few in order to reduce the number so much that there would be enough fodder and grass left for populations to recover after. It just goes to show that the management and forecasts would be very, very important, especially in the light of droughts and climate change. So how could digital image contribute to savanna land management? That's a question. I don't know many wildlife farms that are using digital imagery. And so here, of course, comes the drone project, the SAFMAP mapping project comes into that. So these are basically just in the wild, and we are flying special drones, mapping drones over Cyzicus. And the project started in 2014 with our partners at EPFL and Drone Adventures. And we had a mapping mission every year using the latest tech, the latest drones from SenseFly. And it was never possible to map the whole area, but I have to say that last year we were for the first time able to map the whole area. It took us about 4 weeks, although we could have done it probably in 14, 15 flight hours. I think that's going to change in the future to produce high resolution maps of Cyzicus. And these high resolution maps, they provide maps at a resolution of, let's say, 2 to 3 or 4 pixels per centimeter. That's enough to distinguish between different wildlife species, but also to see surface features of the reserve. On the left, you can see a giraffe, and you can see from the shade that is a giraffe. In the middle, you can see oryx, Gemsbok antelopes, and again, the shape tells you a lot about what type of species it is. And on the right, we see 2 rhinos. We have several publications coming out of the project, and one of the first was basically integrating citizen science into that. So we basically invited people and the social media on a digital safari in Namibia, trying to help and pinpoint which images contain wild animals. Because you have to imagine that if drones fly over the reserve, most of those images do not contain anything, just trees and dead trees and aardvark holes and grasses, but no animals. And of course, everyone wants to see animals. So citizen science helped a great deal, and just to pinpoint and locate those images with animals, which then could be used to produce algorithms. And here's a list of other publications coming from the SAVMAP dataset, and in particular, Benjamin Kellenberger, and working now, I believe, at the EPFL in Sion with Davis Tua and Diego Marcos. They produced some great papers on algorithms. It's a great starting point to quantify a wildlife reserve. Stefan Joost at the EPFL in Lausanne helped to initiate SAVMAP project. Us both together got the first 2 grants to get this project going. Land cover classification is another big potential where machine learning can play a role, and so distinguish between different types of vegetation, grasses and trees. And Marc will tell you more about that. Here's a short summary. This SAVMAP dataset has resulted in scientific publications, and we showed the potential that counting wildlife is possible and also classify vegetation from digital is possible. However, really a practical workflow and application that does not really use, so we can't yet use it and really integrate it into our management. But I think it's a great potential, and all the ingredients are there, but we have to find let's say, a pragmatic approach in order to integrate this into our management strategies. So the goal is to integrate digital image-based wildlife counting as part of a regular workflow into wildlife management. And that's where now we founded WildTake Aachen together with Marc and Christopher. And here's a quick thanks of this part of the presentation. The EPFL Drone Adventures WildTrack helped to fund some of the drone missions, especially the last one, hugely successful. And then Wageningen University was involved with Benjamin Kellenberger working at the time for it. And then the Qatar Research Institute was also involved with Patrick Meyer at the time working there. Pix4D, SenseFly, Skydio providing drones and software, and then students from Imperial College London and also the Namibian University of Science and Technology. So thank you very much, and I'll hand over this presentation to Marc.
Yeah, thank you very much, Friedrich, for this great insight. And I'd like to take the last couple of minutes of this presentation to give you a quick overview of WildTake Aachen together with my colleague, Marc Ungeheuer. I quickly would like to share my screen for you and present the idea of WildTake Aachen. So WildTake Aachen is basically occupied with the idea of developing platform in order to automate quantification of ecosystem. Together with Marc, I watched a documentary in September 2020 on a German television channel, and we watched this documentary about the Kutzikos Nature Reserve in Namibia, basically just where Friedrich was born and raised, and nowadays monitors the whole wildlife there. So we got the idea that there's huge potential for, with our engineering knowledge we could acquire during our studies, to really make a difference, because Friedrich does a great job there with monitoring the wildlife, but there is, for example, such obstacles with keeping track of the whole wildlife with a helicopter and taking notes on a piece of paper. It's very laborious, it's very cost intense, it's time consuming. And we are of the opinion that this can be perfectly automated with machine learning. So we came to the conclusion that we should contact Friedrich, and so we did. We had a quick brainstorming session and exchanged ideas about how to quantify the ecosystem in Namibia, and specifically Kutzikos. So long story short, now we are here today, and just recently we founded our own organization called WildTech Aachen, and there we occupied ourselves with the idea of developing an ecosystem or a platform for quantifying an ecosystem, because we think that even though we are not experts in the wildlife management, we can still contribute a lot to the wildlife management and how to improve the whole workflow there. So, of course, quantifying images taken by drones, so-called UAV, so unmanned aerial vehicles, is nothing new. There's already tons of research done in machine learning, in specifically convolutional neural networks, for example, by Benjamin Kellenberger, as Friedrich has mentioned earlier, or by Beatrix Bacilaga, also from EPFL Lausanne. They've both done research on segmentation of arid areas, but this research has not been put into practice, and that's where basically WildTech Aachen steps in. We would like to develop a user-friendly application that provides people such as Friedrich with tremendous ease, and an application that can be easily implemented in the workflow for his daily routine in managing his wildlife in Namibia. And that's the point where I would like to hand over to Marc already. I quickly stop my presentation here, and Marc, I think the stage is yours.
Hello, everyone. I hope you can see my screen. Yeah, and we have basically developed an automated quantification approach alongside Friedrich and the work that he has already done. And this approach is based on the high-resolution drone images captured by Friedrich. On those drone images, you can really clearly identify loads of details. You can differentiate between bushes. You can identify the shadows. You can identify those animals. And to extract all those different image features, we want to use, or we are using machine learning or different machine learning models, from simple ones like k-nearest neighbors to more complex ones such as UNet and mask-RCNN, to then develop segmentation maps such as the ones shown in the middle here. Firstly, here an KNN segmentation where we clustered the pixels into shadows, trees, grass background, and sand. And then secondly here, mask-RCNN currently showing an aspired output, but at the moment we have it working with dead trees, and artwork holes. And here, as aspired, we want to clearly segment animals, trees, dead trees, all sorts of features on those high resolution images by Friedrich. And this will allow us to fully completely quantify ecosystems by extracting all sorts of data from those segmentation maps. So Friedrich will all of a sudden have access to, for example, the number of animals, the number of trees by species, the position of artwork holes, or the artwork hole distribution in general, yeah, all this data together, I think, will provide completely new insights into his Kutzikos ecosystem and other ecosystems potentially as well. And yeah, basically, want to develop a platform now where he can make use of all these different machine learning features. And we have split this machine learning, or those machine learning advantages into, or to bring those machine learning advantages to his wildlife conservation work, we have split into 3 different core functionalities. Firstly, white label, where we want to enable him using an aided labeling tool to, with large teams, aid large amounts of his data sets, such that models can be developed while ensuring annotation quality through control by domain experts. And then the second function would be wild AI, where we want to allow him to train pre-selected machine learning models without having any programming knowledge himself, or where the user doesn't have any programming knowledge. So we would provide, for example, a pre-trained mask RCNN, then the function to allow him to add a new data set with, I don't know, new images that he has annotated over time, and that will improve our models that we're using in future and ensure the long-term usefulness of the whole program. And then thirdly, this would be wild analysis, where we basically want to provide a visualization of all the data that we have extracted to then use that data to develop strategies to counter some of the challenges that he is facing and has already mentioned in this part of the presentation. But yeah, the key message here is we want to enable him to make use of machine learning, and we are looking forward to start testing our first sample application that we have finished by now, or almost finished by now, and which allows him to count trees on any given orthomosaic, get the position of the tree and the size, and defer all sorts of additional data from that. And this is, I think, something that is great about Kurzikos. You can really iteratively test all the functions that we are developing and see what kind of changes and what kind of impact you can have with those with that effort. And at the same time, as well as developing that platform and implementing the research mentioned by Friedrich and Christopher, we also want to push computer vision in wildlife protection by 3 research projects and future ones as well. So the first one being an acacia type segmentation, where we use where we are developing a classification network to differentiate between different tree species. Why would that be interesting? A rhino likes a certain acacia type, whereas a giraffe likes a certain other acacia type. And to, for example, forecast the food mass available for them in the coming month, you need to differentiate between those 2 different acacia types. Then the second research project would be a shadow classification, where we basically make use of the sun shining at those objects to get a new view on the bird's eye image that we are provided with, and want to classify maybe different animals based on shadows, but also want to classify tree shadows. And why would that be interesting? Well, from if you draw a fit through that shadow contour over here, you can estimate the tree height based on the angle of the sun in the moment that the picture was taken, and then maybe even approximate the volume of the tree, leading to all sorts of more accurate food mass estimations, or estimations, forecasts. And then our last project would be a simple dead tree and artwork hole detection network, where we use mask RCNN to detect artwork holes in dead trees. Artwork holes in general serve as an indicator of the health for the ecosystem, so knowing where they are and how many they are is great for Friedrich, because again, it's an approximation of ecosystem health. And then the trees in general provide micro ecosystems to small organisms, organisms. And then we want to stress here again that the Kurzikos dataset in general provides many interesting challenges for computer vision based analysis, and we're looking for coming challenges once we have solved those or tackled those in the future. 1 second. Yeah, so just simply to stress what we do in summary, I think that is an interesting message maybe for you as well. We are just simply a group of students in Germany, and we thought that we could maybe do something about wildlife conservation in Namibia, and through the internet that is totally possible. So if you feel like you want to make a difference in wildlife conservation, it's very easy to contact Friedrich and ask him, or you can help him, brainstorm with him. I think that is something we've demonstrated. Then we are advancing the current research in the field of wildlife conservation by bringing more computer vision based technologies to the field. And then lastly, and I think that summarizes us best, we are integrating machine learning in the workflow of wildlife conservation for ecosystem protection. And we are we are continuing to be a non-profit organization. I don't think there's much money to make in this industry, but I think there's a lot of good to do. And if you feel like you want to support us, if you have ideas, if you think that you could provide us with scientific guidance in the field of computer vision, if you have financial support or computational capabilities, please contact us. We are very open for any of those for things mentioned or other requests. So take a screenshot of the QR code. This will lead us to our website. And yeah, I'm looking forward to questions too as well, to me, Christopher, and I guess especially Friedrich, if you have some. Thank you.
So, Antonio, are you still with us?
Yes, this is a remarkable project, and congratulations to all of you, because it's a very smart and sensible application of machine learning to a very important problem. So it was just a terrific, really amazing intermezzo. So thank you very much for that. And I give back to the organizers. Thanks.
Well, thank you, first of all, Professor Dieva, for chairing this session. Thanks to all the speakers, especially our keynote speakers, Friedrich, Marc, Chris. Thank you for coming. Do we have any questions from the chat?
Thank you.
I don't think so. Do we have any questions from any of the speakers who are still logged in? If not, then we will give you 10 minutes to digest after this basic introduction, and we will be back in about 10 minutes with the session on the challenges of really implementing machine learning in clinical practice. Professor Dieva, do you have anything to say?
No, thank you so much for organizing that. The first session has been amazing, and I'm looking forward to hearing all the other speakers.
So have a good night, and you're in Australia right now.
Sleep well.
It's starting to get late, but I will keep going. Don't worry.
Person here in Zurich. See you soon.